All right, what's going on, everybody? Today we're going to be doing another LeetCode problem. This one's called reverse nodes in K group. So they basically give us a linked list and they want us to reverse the nodes K at a time and then return that modified list. So rather than just reversing an entire linked list, we're going to be reversing the list in K node segments. So what that means, like, let's look at these examples. So for this example, if we were given this list just containing nodes labeled 1, 2, 3, 4, 5, and if they give us the integer 2 for K, they'd want us to reverse the list in segments that are length 2. So this 1 and this 2, this would be a segment that would get reversed, as you can see in the output. This 3 and the 4, that would be the second segment of 2 nodes, that would be 4, 3. And then this 5 is by itself, and they specify that if there are not K nodes at the end of the list, then you just leave it alone. So a better example of what they mean by that is in the second example. So here K equals 3. You know, we would reverse this segment of K nodes here. So this 1, 2, 3 becomes 3, 2, 1. But the end we're not going to touch because there are not 3 nodes. There are not K nodes there to reverse, so we just leave it. And we return, we modify that in place, and then we return the head of the list. So in a nutshell, that's basically the problem statement. So let's get into whiteboarding. So one of the things that I found challenging on this problem is we know how to, first off, we know how to reverse a linked list, right? I mean, it's a easy list problem, but the difficulty is reattaching the segments in an elegant way once we reverse them. So before I get into stepping through the algorithm for this problem, let's just go ahead and do basically solve this manually, right? Before we do any kind of algorithmic stuff. So the solution to this, right, this is literally the same as one of the example input outputs, but we would reverse these 2 nodes, right? So 2 would point to 1, and then that's, you know, the first segment of K nodes, and we need to reverse the next segment of K nodes. So this 4 would come before the 3. And then finally, there's 1 node at the end, and that's less than K, so we can just leave it as is. It's the 5, and then that obviously, just points to null because it's the end of the list. And then we would return a pointer, basically to the head node here, and that would be the answer. So yeah, let's get into the algorithm. So the first thing we're going to want to do is we need a dummy node. So we're going to allocate space for a dummy node. And I'll just label that D because the value doesn't actually matter. And we're going to point that to the head of the list just to keep track of that. We're also going to have 2 pointers to keep track of the segment that we're currently on. So we're going to have a pointer called begin. And at first, that will point to our dummy node. And then we're going to have a pointer called end. And that'll point to our head node. So we're also going to need basically a fast pointer to see if we even want to bother reversing the segment we're on to begin with, right? Because if there aren't K nodes to reverse, then we don't need to do anything. So our fast pointer will point to the head node at first, and basically the first thing we're going to do for our algorithm is just move that fast pointer down 2 nodes. So 1, 2, and 2 nodes because K equals 2, right? So our fast pointer will be here after we do that. Okay, and fast does have a node, so we know we want to reverse these 2 nodes. So now at this point, we're going to get into basically just reversing the segment. It's pretty much just going to be reversing a linked list as normal. So we're going to have a previous node, a current node, and a next node. Now the previous node at first is going to point to whatever node the beginning node pointer is pointing to. So our previous node will be here, and then our current node will be whatever the end node is pointing to. So our current node will be there. So at this point, we can begin reversing our segment as normal, and we're basically going to run the linked list reversal algorithm twice. So we're just going to do a C-style for loop. We're going to execute this twice, very similarly to the way we moved our fast pointer down. So to reverse this list segment, we need our next pointer is going to be pointing to whatever current is pointing to, whatever the current node's pointing to next. So, because we need to maintain the rest of the list, right, so we don't lose it. At that point, we can reverse the current next pointer. So current next will get set to previous, which is the dummy node. And then we can slide down our previous and current pointers. So current will get pointed to whatever next is pointing to, and previous will get pointed to whatever current was before. Okay, and we're going to do this twice, right? So that's one iteration of our loop reversal. So we need to maintain the rest of that list. So next will be whatever that current node is pointing to next, and then we can safely reverse this current next arrow. So current next will get pointed to that previous node pointer, and after that we can slide down previous to whatever current is, and then current to whatever next is. So previous will be here, and then current will be here. Okay, so that's two iterations. Now, so here's the difficulty. So this is why we have these two pointers, right? Because we now need to basically reintegrate or reattach this segment that we just reversed back into our list. So the way we're going to do that is we're going to set whatever our beginning node is pointing to next to the previous node pointer. So this dummy node is our what the beginning node is pointing to. So this is going to point to this previous node. So that will be like so. And then we're going to do something very similar for our end node. So whatever end node is pointing to next, that needs to point to the current node. So we're basically, so the previous node is kind of like the head, or it literally is the head of our reverse segment, and the current node represents the head of the rest of the list, right? So we're going to point this end next to the head of the rest of the list, which is our being kept track of by our current node pointer. So this end next is going to get pointed to this current node. So, and I'll just go straight through those. So that's pretty much it for one iteration. I mean, there is one more thing we need to do. We need to reset these segment indicators, or these segment markers, beginning and end. And the way we do that is beginning is going to get set to the end. So beginning is now what this end pointer was, and then our end pointer is going to be set to whatever our current node pointer is pointing to. So our end node is now this. Okay, so it's a lot going on there, but that is an entire iteration basically of our algorithm. So let's go through that again, and hopefully it'll start catching on more the second time. So once again, we need to move our fast pointer down 2 nodes. So, because k equals 2, so 1, 2, and then our fast pointer will get pointed there. Okay, and the fast pointer does point to a node, so we know we can reverse those last 2 nodes. So we need to basically assign those previous, current, and next pointers for our segment reversal. So our previous pointer will get pointed to, will be pointed to whatever the beginning node pointer is pointing to, and then the current node will be pointing to whatever the end node is pointing to. So this 3. Okay, so now we can proceed with reversing this linked list segment. We'll iterate twice, just as a reminder. So we need to preserve the rest of the list, so that's the first step there with our next pointer. Now we can safely reverse this arrow. So this 3 will basically get pointed to whatever the previous node is pointing to. So this 1. Oops. Okay, and then our previous gets set to the where current's pointing to, and then current is pointing to whatever next pointing to. So previous is now there, and then current will be here. Okay, so at this point we can go into our next iteration. So the next pointer will be pointing here, and we can safely reverse this now. So this will go back to the 3, right? Because it's going to go to whatever the previous pointer is pointing to, whichever node that is, which is in this case the 3. And then we can slide down those previous and current pointers again. Current will be there, and then previous will be here. Okay, now we can reattach our segment. So once again, the way we do that is beginning next is going to get set to whatever the previous, wherever the previous pointer ended up. So in that case, it's the 4. So we're going to point this 1 to our 4, and we also need to, so what we just did basically is we attached the beginning of our so basically the preceding node to the segment we just reversed to the head of the segment we just reversed. And we also need to reattach the end of the segment we reversed to the rest of the list, right? So to do that, we'll set end next to the current node. So this will get pointed here. Okay, so at this point we can go ahead and move our move those segment markers. So begin gets set to end, and then end gets set to the current. And then let's erase those old ones. So at this point we're here. You know, we don't need to worry really about these anymore. So now we're at another iteration. We need to, again, move our fast pointer down 2 nodes, or try to, but notice fast pointer reaches null here. So as soon as the fast pointer reaches null, we know we've reached the end of our list. There's no more reversing to do, so we can basically return a pointer to the head of the list. So let's just erase these and erase this because we're done with it. What we need to do is basically deallocate this, but also, you know, keep track of the head of the list and just return a pointer to it. So as you can see, this basically reflects the solution here. So 2 points to 1, which points to 4, which points to 3, which points to 5. So I know this looks a little wonky, but it is the solution here. So we just return a pointer to that 2. So again, for the time and space complexity for this algorithm, the time is just going to be big O of n, right? Because we need to look at every single node in our list, but we're not doing any kind of nested looping or anything like that. So it's just linear time, and then the space is going to be big O of 1, which is going to be constant because we're not using any extra data structures to do this. So yeah, so let's go ahead and get into the code. So the first thing that we need is that dummy node. So let's allocate space for it. So we're gonna have a dummy pointer that points to a new space allocation for a list node. Doesn't need a value or anything because we're just gonna use this to keep track of the head of our list. So we're gonna point that to the head. So dummy next will get assigned to the head. And so let's go ahead and handle the assignment of our variables before we get into actually iterating through the algorithm. So the first variables we'll declare, we need some segment markers, right? These are going to be like those beginning and end pointers that'll allow us to elegantly reattach our reverse segment to the rest of the list. So segment markers, we'll have a list node called begin. That'll just be pointed to the dummy node at first, and then we'll have one called end, and at first that'll point to the head of the list. Okay, so those are our segment markers. We also need reversal markers, right? And when I say marker, I mean these are obviously node pointers, but we need reversal markers. So that'll be the previous, current, and next pointers that'll help us reverse a segment. So this node, previous, these will all be null pointer at first. So current, null pointer, and then next. Okay, and after that, there's only one more variable we need. We need a pointer for that fast node pointer, right? To basically check and see if we can reverse a segment of nodes. So, and I won't write a comment for that. I think it's this one should be pretty straightforward. So fast, and that'll just point to the head of the list at first. So we're just gonna loop while true for the outer part of our loop. And the first thing that we can do is just move our fast pointer down through k times, right? So however many nodes it wants us to reverse at a time. So we'll just do a C style for loop. So for n I equals 0, while I is less than k, I plus plus, we're just incrementing I k times. And within this loop, we can actually, so if our fast node is a null pointer, we know we've reached the end of the list. We know we can return our list, basically a pointer just to the head of the list, right? So, and we need to deallocate space for the dummy node we created. So let's just go ahead and get that out of the way first. So we're going to, first thing we can do, we can just recycle our current node, because in this block of code, we're going to be exiting from our algorithm. So we're just using this to help us deallocate space for our dummy node. So current will be dummy. We can assign dummy to dummy's next node, and then we can deallocate the space for current and then return that dummy node, and that will be the head of the list. And we've handled preventing the memory leak for this dummy node. Okay, so if fast does point to a node, we need to keep sliding it down the list. So fast will get assigned to fast next node. And so at that point, let me leave a comment here. So basically what we're doing here is we're check to see if we can reverse k nodes. Okay, so if we've gotten this far, we know we can reverse k nodes. Otherwise, we would have, returned from this entire function. So at this point, we know we can reverse those nodes. So our previous pointer is going to point to the beginning segment, and then our current or beginning segment pointer, and the current reversal pointer will be assigned to our end segment pointer. So, and let me leave a comment on what we're doing here. So at this point, we're reversing a reverse segment of k nodes. Okay, so we need to reverse, or basically do the list reversal iteration k times, right? So very similar to how we moved our fast pointer. So just a C-style for loop. And at this point, this is exactly like reversing a linked list, the LeetCode easy problem. So, so current next, we need to preserve that, right? So next will get set to current next, and then we can safely repoint current next to whatever was before it, so previous, and then we can slide our current node or our previous node to whatever the current node was, and then our current node to whatever the next node was. And at that point, the segment of k nodes will be reversed. But now it's kind of the pointers at the beginning and end aren't handled correctly. We need to reattach this, reintegrate it back into the rest of the list, right? So I'll just say reattach segment back into list. Okay, so to do that, our beginning, the begin node marker, whatever that's pointing to next. So this is basically like reattaching the end of the list before that to the head of the part that we just reversed. And the head of the part that we just reversed is the previous pointer. Okay, so then we need to handle the end. So the end segment marker is the end of the segment that we just reversed, and we need to basically attach that to the remaining portion of the rest of the list, right? So, and that's going to be marked by our current node pointer. Okay, so at that point we're basically done. We need to reset those segment markers for the next iteration. So reset for next iteration. Okay, so the beginning pointer will just get assigned to whatever the end pointer was, basically to move that segment down like an entire k length, and then the end pointer will get assigned to that current pointer that we just left off at in our segment reversal. So this is pretty much it for the code. So let me zoom out so we can see all of this. It's about 50 lines, but this is more or less the optimal approach here. So hopefully this video helped you understand the problem better. If it did, please leave a like and subscribe. It helps the channel, and I'll see you guys in the next video. Peace.